Hello everyone. So welcome back to yet another lecture on matrix and determinant. So in this particular lecture, we are going to discuss two very important topic, which is adjoint of a matrix and inverse of a matrix. And both these matrices are related to each other. So without knowing the adjoint of a matrix, we cannot find inverse of a matrix. But before coming to this particular lecture, आप लोगों को थोड़ा minor and cofactor or how to expand or how to find the determinant of a 3 by 3 and 4 by 4 matrix, तो उसका थोड़ा आइडिया हमें चाहिए. So I'll suggest you before coming to this particular lecture, go and please watch those two videos on minor and cofactor and how to find the determinant of a 3 by 3 and 4 by 4 matrix. So both the videos you'll find in playlist under matrix and determinant. So kindly go and watch those two particular videos first, and then if you come to this particular lecture, then it will be very much useful to you. Okay, so let's get started. Now what is adjoint of a matrix? So to find the adjoint of a matrix, first हमें क्या करना होगा, एक matrix लेना होगा. Now see, this particular matrix should be a square matrix. Okay, so adjoint निकालने के लिए पहले हमें क्या चाहिए, एक square matrix चाहिए. So what do you understand from here? If we take a non-square matrix, suppose एक matrix है वो square matrix नहीं है, then we cannot find the adjoint of that particular matrix. Okay, then the definition will be like this: the transpose of the cofactor matrix of capital A is called adjoint matrix of A. Okay, so it is denoted by how will denote it? ADJ A, adjoint of A. आप लोग small letter भी लिख सकते हैं. So ADJ small a. Okay, now two important word is cofactor and then what? Transpose. So you know how to find the transpose of a matrix by interchanging what? Rows and columns. And cofactor, so you already learned how to find cofactor in our previous lecture. So that's why I asked you, kindly go and watch that particular video first, how to find minor and cofactor of a matrix. Okay, so then it will be very much easy for you. Now let us take an example how to find the adjoint matrix. Okay, so for example, okay, so let us take this particular example. So this is a 3 by 3 matrix. So you can find a 2 by 2 matrix also. Suppose capital A equals to A, B, C and what? D. So to find the adjoint matrix, first हमें क्या करना होगा? कोफैक्टर निकालना होगा. A11, A12, A21 and then what? A22. So already we know how to find the cofactors in our last lecture. Okay, so पहले हमें क्या देखना होगा? 1 1. Okay, so 1 plus 1 is how much? Even number. So if it is even, then plus. Next one is 1 2. 1 plus 2 is what? 3 odd. If it is odd, then negative. Here it is 2 1. तो 2 1 होने से फिर से odd है, negative. और last one is how much? 2 plus 2 is 4. So ये क्या? Positive. तो पहले हमें ये symbol use करना होगा. So cofactor either we can denote by capital letter A or we can use capital C also. So no problem. Whatever you like you can use. Now A11. So A11 मतलब याद है ना? So ये जो A है, so we have A cofactor of A11 means cofactor of this particular element small a. So what we'll do? We'll delete first row and first column, right? Because A lies in first row and first column. So if we delete first row and first column, हमें क्या मिलेगा? D. Then 1 2. 1 2 means we are going to find the cofactor of the element B. So B का cofactor. So B lies in first row but in second column. So what we'll do? We'll delete first row and second column. So क्या दिखाई दे रहा है? C. So we'll get C. Similarly, next A21. A21 means which element? C. So if we want to find a cofactor of C, then we have to delete first column and what? Second row. So after deleting first column and second row, you will see only B. Okay, and then finally for D we have to delete second row and second column. So you'll get how much? A. So these are the cofactor. Okay, these are the cofactor. Now first of all you have to write the cofactor matrix. Cofactor matrix. Okay, cofactor matrix. Cofactor matrix means which contains the cofactors. What are the cofactor? D minus C minus B and then what? A. Okay, now see, without finding the cofactor you can write it directly. How? You see, interchange the diagonal. In diagonal what we have? AD. Now we are writing DA. So interchange the diagonal, and other two elements of you have to interchange but with negative sign. So it is CB, but here we are writing minus B and minus A. So you can write it directly also. So someone says that this is shortcut. So if it is shortcut, then directly you can write this one. So first you have to write the cofactor matrix. So this is our cofactor matrix. Now what says in the definition? The transpose of the cofactor matrix. So पहले हमें cofactor matrix निकालना है, फिर उसका transpose लेना है. So that particular matrix is called what? Adjoint of A. So what is adjoint? Adjoint is nothing but the transpose of the cofactor matrix. So transpose कैसे निकलता है? So here this first row, no? This first row we have to write in first column D minus C, and then second row we have to write in second column minus B and then what? A. So this is the transpose of a matrix. So it's very simple. First you find the cofactor, फिर आप लोग उसका cofactor matrix लिखिए and then take what? Transpose. Okay, so let us take a 3x3 example. So now we'll find the adjoint of this particular matrix, which is a 3x3 matrix. So first हमें क्या करना होगा? We'll write the cofactor A11, A12, A13, then A21, A22, A23, and then A31, A32, and then A33. Okay, so since these are cofactors, so you have to write minus 1 to the power 1 plus 1. Okay, so I have discussed that. So without writing all those things, just you have to check that the position of that particular cofactor is even or odd. So here it is 1 plus 1 is positive, then it is negative. Alternatively you can write, if the first term is positive then negative, surely next will be positive, plus minus plus minus plus minus plus minus and then what? Plus. Okay, so first you have to give this particular symbol. So if you don't want to write positive sign, then you can skip it, but negative you have to write. Okay, so ये 1 plus 1 था, 1 plus 1 क्या है? इवन है, so इसलिए प्लस, 1 plus 2 ऑड है, so ये नेगेटिव, फिर 1 plus 3 क्या है? Even number, so again what? Plus. So we have already discussed how to find the cofactor. So when you will find the cofactor, so A11 means what? Cofactor of the element 1. So 1 lies in which row? First row and first column, right? So 1 lies in first row and first column. So we have to delete these two. Okay, so we have to delete these two. So how much element you'll see here? Remaining 4 element. Okay, so those 4 element we have to write here 1, then minus 3, 2, and then what? 3. Okay, so let us break it. So it is 3 minus then minus 6. Okay, how much it is? 9. So like this we can find the other cofactors also. Next, A12. So for A12 I am talking about this particular element, no? 1. A12 means cofactor of 1. So delete first row and second column. So first row second column delete करने के बाद क्या मिलेगा? 2 minus 3, then minus 1 and then what? 3. Okay, is it all right? 2 minus 3 minus 1 and 3. So if you expand it, so it's how much? 6, then minus, it is minus plus 3, so you will get minus 3, right? This is the second cofactor. Then third one. So next A13 means we are going to find the cofactor for this one. So this one lies in first row and third column. So delete first row and third column. So what you will see? 2, 1, minus 1 and then what? 2. Okay, so let us split it. 4 minus, again this into this, how much? Minus 1. So you will get how much? 5. Okay, so 3 cofactor हमें मिल गया. Next A21. A21 means which element? This particular element 2. Okay, अभी ये 2 कहाँ पे है? This lies in second row and first column. सो विल डिलीट सेकेंड रो एंड फर्स्ट कॉलम। तो सेकेंड रो और फर्स्ट कॉलम डिलीट करने के बाद क्या आएगा, 1 1 एंड देन 2 एंड देन व्हाट 3, ओके 1 1 2 3. So if we break it, it's 3 minus 2. So how much it is? Minus 1. Then A22. So A22 means we are going to find the cofactor for this particular element 1. So 1 कहाँ पे है? 1 lies in second row and second column. So we have to delete second row and second column. ठीक है, second row और second column delete करने के बाद कौन सा element आएगा? 1 1 and then minus 1 and then what 3. ठीक है, 1 1 minus 1 3. If you split it, 1 into 3 is 3 minus, then ये दोनों multiply करने से minus 1. So how much it is? 4. Okay, this is 4. Then A23. 23 means we are talking about minus 3. So minus 3 lies in second row and third column. So delete second row and third column. So how much you will get? 1 1 minus 1 and then what 2. ठीक है ना? So this particular element, this and this, yes. So minus, now it is 2 minus minus plus 1, so you'll get minus 3. Okay, so these are the first 6 cofactor. Now let us find the last 3. A31. A31 means we are talking about minus 1. So for minus 1 we have to see minus 1 lies in first column and third row. So if we delete first column and third row, what will get? 1 1 1 and then what? Minus 3. Now let us split it. If we expand the determinant, it's minus 3 then minus 1. So how much it is? Minus 4. Then A32. So A32 means we are talking about 2. 2 lies in second column and third row. So delete second row, second column and third row. So 1 1 and then 2 minus 3. ठीक है, so 1 1 2 minus 3. So it's minus 3 minus 2. So you'll get 5. And then the last element. So last element means A33. So we are talking about the cofactor of 3. 3 lies in third row, third column. So after deleting third row and third column, how much you'll get? 1 minus 2. How much it is? Minus 1. ठीक है, so we have all the cofactors now. So how many cofactors we have? 9. हम लोग के पास 9 cofactor है. So पहले हमें क्या करना होगा, ये जो 9 cofactor है, ये cofactor को हमें cofactor matrix में लिखना है, एक matrix form में लिखना है, cofactor matrix. So you can skip this particular line also. I'll explain how. So मैंने last video में बोला था that if it is a 3 by 3 matrix, then write 3 cofactors in one line. ठीक है, so A11, A12 and A13. So write in one line. So क्या क्या है? 9 minus 3 5. Okay, then minus 1 4 minus 3 minus 4 5 and then how much? Minus 1. So this is our cofactor matrix. So what is adjoint matrix? So adjoint क्या है? adjoint हम लोग कैसे निकालेंगे? We have to take the transpose of the cofactor matrix. So जो cofactor matrix है उसको transpose लेना है. Transpose मतलब रो और कॉलम को इंटरचेंज करना है. So जो पहला रो था उसे हमें फर्स्ट कॉलम में लिखना है, 9 minus 3 5 एंड देन जो सेकेंड रो है उसे हमें सेकेंड कॉलम में लिखना है, minus 3 एंड देन थर्ड रो इन थर्ड कॉलम. ठीक है, रो और कॉलम को इंटरचेंज करना है. सो यू आर गेटिंग ए न्यू मैट्रिक्स. सो यही क्या है? दिस इज द एडजॉइंट ऑफ द ओरिजिनल मैट्रिक्स. तो क्वेश्चन में जो मैट्रिक्स दिया हुआ था, सो वी आर फाइंडिंग द एडजॉइंट ऑफ दिस पर्टिकुलर मैट्रिक्स. तो सपोज we don't want to write this cofactor matrix. Okay, so then also it is possible. You see the first 3 element, no, 9 minus 3 and what 5. So these 3 elements are in horizontal line. So what to do? You write these 3 element in what vertically. Directly you can write. Okay, जो 3 element horizontal में था उसको फर्स्ट कॉलम में लिखिए. नेक्स्ट जो 3 element है -1 4 और कितना -3, उसे आप लोग डायरेक्टली सेकेंड कॉलम में लिखिए. एंड देन -4 5 एंड -1, यू जस्ट राइट डाउन दिस 3 एलिमेंट इन थर्ड कॉलम. सो ये जो स्टेप है कोफैक्टर वाला स्टेप, यू कैन स्किप दिस पर्टिकुलर स्टेप. ओके, सो आई होप adjoint is very much clear to you. Now coming to the inverse of a matrix. Okay, this is again very much important. because without knowing the inverse of a matrix we cannot solve simultaneous equation. So in our next video we'll solve matrix equations. We will solve some equation by what? Matrix equation. So that video is also very much important. So for that particular video we have to understand how to find the inverse of a matrix. Okay, तो inverse कैसे निकालते हैं? Suppose capital A is a matrix. Okay, obviously it is a square matrix. Capital A is a matrix. Then we will take another matrix B. B is the inverse of the matrix. B is the inverse of the matrix A if, what is the condition? A into B or B into A must be equals to what? Identity matrix. So जैसे suppose मान लीजिए 2, what is the inverse of 2? Inverse of 2 is half. Why? Because 2 into half is how much? 1. So in matrix it is like that. Matrix में तो 1 नहीं होता है, वहाँ पे क्या होता है? Identity matrix. So suppose capital A एक matrix है, तो उसका इन्वर्स मैट्रिक्स कौन सा होगा? B. कब? अगर A और B को मल्टीप्लाई करने के बाद इफ वी गेट द आइडेंटिटी मैट्रिक्स. ओके, एंड हाउ वी राइट इट? A इनवर्स. सो A का इनवर्स कौन सा मैट्रिक्स है? B. बट इन प्रॉब्लम वी आर नॉट गोइंग टू यूज दिस पर्टिकुलर डेफिनेशन. इन प्रॉब्लम वी विल यूज ए डिफरेंट डेफिनेशन. A इनवर्स उसका फॉर्मूला है 1 by डिटर्मिनेंट A इंटू एडजॉइंट ऑफ A. Okay, 1 by determinant A into adjoint A, provided determinant A is what? Not equal to 0. So I think you still remember what is determinant A not equal to 0 called ना? Determinant A अगर not equal to 0 है, पहला जो इंट्रोडक्शन वीडियो था मैट्रिक्स और डिटरमिनेंट का, वहाँ पे था if determinant A is not equal to 0 तो the matrix is called what? नॉन सिंगुलर. तो मैट्रिक्स को नॉन सिंगुलर होना पड़ेगा इन्वर्स निकालने के लिए. ओके, इफ डिटर्मिनेंट A equals to 0 तो उस पर्टिकुलर मैट्रिक्स का इन्वर्स एग्जिस्ट नहीं होता है. Okay, now let us take an example. Okay, so it is better if we take the last example because वहाँ पे already हम लोग adjoint निकाल, मतलब वहाँ पे already हम लोग का adjoint है. So find the inverse of the matrix. Find the inverse of the matrix 1 1 1 2 1 minus 3 minus 1 2 and then 3. ठीक है. ओके, सो टू फाइंड द इनवर्स फर्स्ट हमें चेक करना होगा, उसका डिटरमिनेंट वैल्यू निकालना होगा. ओके, सो डिटरमिनेंट कैसे निकालता है उसका भी लेक्चर ऑलरेडी मतलब आप लोगों को मिल जाएगा. सो काइंडली यू वॉच दैट पर्टिकुलर लेक्चर हाउ टू find the determinant of a 3 by 3 matrix. So 2 and then what? 3. So what we'll do, we'll consider the first row. So in first row how many elements we have? 1 1 and then 1. Then क्या लिखना है? Plus minus plus depending on the position of the element. Then 1. So 1 lies in first row and first column. So first row और first column हमें delete करना होगा. क्या लेना होगा? 1 minus 3 2 and then 3. ठीक है. Then दूसरा जो 1 है ये lies in first row and second column. So if we delete first row and second column we will get this 4 element and finally हमें इस 1 के लिए first row third column delete करना है. So we will get minus 1 and then what? 2. Okay, so first is 1 minus 3 2 3. Okay, then 2 minus 3 minus 1 3, right? Then last one is 2 1 minus 1. Okay, so if you split it, it is 3 minus, then minus minus is minus 6. Okay, then 6 minus 3 and then it is 4 minus minus 1. So how much we will get? 9 minus 3 and here how much you will get? 4 plus 1 5, right? 5. So it is 11. So it's not equal to 0. ठीक है. So therefore A inverse exists. Okay, A inverse exists. A inverse exists. So if A inverse exists, that means we can find the inverse of the matrix. So already we know or what is the adjoint of this particular matrix. आप लोग इसको पूरा निकालिए adjoint of A. So already in this particular problem, no, we got what is the adjoint of A तो यहाँ पे मैं उसको डायरेक्टली लिख रहा हूँ. सो adjoint of A, what is adjoint of A? So how much it is? 9 minus 1 minus 4 minus 3 4 5 and then 5 minus 3 minus 1. ओके, सो एक बार चेक कर लेते हैं. 9 minus 1 minus 4. Yeah. Okay, now what is A inverse? So formula क्या था? 1 by determinant A into adjoint of A. So determinant A is how much? 11. Okay, determinant A is 11, and then this is the adjoint matrix. 9 minus 1 minus 4 minus 3 4 5 5 minus 3 minus 1. So now what to do? We have to multiply all the elements by 1 by 11. So it will be 9 by 11 minus 1 by 11 minus 4 by 11. ठीक है. So minus 3 by 11, 4 by 11, 5 by 11, again 5 by 11, minus 3 by 11, and then minus 1 by 11. So this is how we can find the inverse of a square matrix. Okay, so आप लोग इसको verify भी कर सकते हैं, ये correct है ये incorrect है. So if you multiply A and A inverse, and if you get identity matrix मतलब कितना? 1 0 0 0 1 0 and then what? 0 0 1. So अगर ये मिलता है, that means problem में कहीं पे कैलकुलेशन में रॉन्ग नहीं है. सो इट इज परफेक्टली व्हाट करेक्ट. ओके, सो आई होप both the things, that is adjoint of a matrix and inverse of a matrix, are very much clear to all of you. So I'll expect that you'll practice some more problems, and if you like my video, kindly share with your friends so that others also can get the knowledge. And thank you very much for watching.